In this class, I am going to explain about digital logic gates. The most basic elements of digital circuits are logic gates. The most basic types of electronic circuits designed with active devices such as diodes, transistors, and passive components such as resistors, which consists of two or more inputs and one output. Performing very basic logic operation are called logic gate. Basically, logic gates are classified into three categories. Logic gates divided in three categories: basic gates, universal gates, special gates. So again, basic gates are divided into four types: NOT gate, AND gate, OR gate, buffer gate. Okay, na? So coming to the universal gates, NAND gate and NOR gate are the universal gate. So why you are calling NAND and NOR are universal gates means, so by using these gates we can design all other gates. Okay, and so third classification of logic gates are special purpose gates: XOR gate, XNOR gate. We'll discuss one by one. Okay, so what is a gate? Gate is a medium which has some input and gives one output. So gates are used to design the digital circuits. Okay, na? So first we'll see a NOT gate. So first NOT gate. So NOT gate, the output will be complement of the input. The output is complement of the input. For example, so I am giving 0 as my input. Okay, na? So sorry, I am giving 0 as my input. I'll get 1 output. So when I'm giving 1 is input, 0 as output. So this is a symbol of a NOT gate. So here, this is a symbol of a NOT gate. Okay, na? So A is input and Y is the output. So NOT gate has only single input and single output. All the gates has single output only, but NOT gate has only single input, and remaining all other gates may has two or more than two inputs, but NOT gate has only single input. Okay, na? So this is a symbol of NOT gate, and this is a truth table of NOT gate. Okay, na? So whenever I am giving 0 as my input, I am going to get 1 as my output. So this is the input and this is the output. So when I am giving input 1 to the inverter gate or NOT gate, it is going to give output 0. So NOT gate, or it is also called as inverter gate, also inverting gate. Okay, this is about NOT gate. So the mathematical expression is y equal to a bar. Okay, na? For example, input A I am giving 0, so a bar nothing but 1. A I am giving input 0, output of NOT gate is 1. If I am input I am giving A as 1, a bar nothing but what? Output is 0. So if simple, if I am giving 0, 1 will be the output. If I am giving 1, output is a 0. This is a inverter gate or NOT gate. Okay. Right. Next gate we are going to discuss about AND gate. So AND gate has two or more inputs and it produces single output. This is nothing but a AND gate. Okay, AND gate has two inputs, more minimum two or more than two, right? So the output will be high if and only if all the inputs are high. Okay, na? So internally AND gate performs a product operation. This is about AND gate. Okay, na? So I am giving input A, B as input. So output Y equal to AB means A product of B. Internally it can perform a multiplication operation. Okay, so this is a multiplication operation. Here I have taken three inputs. Okay, na? So here the circuit is like this. I am giving three inputs: A, B, C, and output Y equal to A, B, C. Okay, na? See, so we are giving three inputs. Now how many combinations will come? 8, because 2 to 4 of 3 equal to 8 combinations. That's why 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So these are the, I am giving three inputs. That's why I got 8 possible outputs. Okay, na? Right, 8 possible combinations. Okay, what is the AND gate? So whenever all the inputs are high, So output is also high because y equal to a into b into c. 1 into 1 into 1 nothing but I am going to get output is 1. If any one of the input is 0, if any one of the input is 0, output is 0. If any one of the input is 0, output is 0. So here two zeros, output is 0. And here single 0 is there, output is 0 because like let me take a equal to 0, b equal to 1, c equal to 1. A equal to 1, right? Sorry, a equal to 0, b equal to 1, c equal to 1 I am taking. So y equal to a into b into c. So 0 into 1 into 1. So output I get 0. Simple. If all the inputs are high, the output is high. This is about AND gate. Okay, na? So AND gate has minimum 2 inputs. Okay, na? Minimum 2 inputs and more than 2 inputs. So here this is a 3 input AND gate we have discussed. Okay, so output is the product of all the inputs. Okay, this is about the AND gate. For example, you will take 2 input AND gate. Okay, na? So this is a 2 input AND gate. Okay, na? The inputs are a, b are the inputs. Okay, na? So two inputs are there. Now how many combinations? 4 combinations. 0 0 0 1 1 0 1 1 because 2 power 2 nothing but a 4 combinations. The output y equal to ab. Okay, na? So 0 into 0 0 0 into 1 1 1 into 0 into 1 0 1 into 0 0 1 into 1 1. Internally it performs a mathematical, okay, na, product operation or multiplication operation. When both inputs are high, our output is high. Remaining all the cases, if any one of the input is 0, if any one of the input is 0, output is 0. Here any one of the input, here 0, that's why I got output 0. Here 1 0 is there, output I got 0. Here 1 0 is there, output I got 0. This is nothing but an AND gate. Okay, now so AND gate, so output is the product of two input signals. Clear? Right. So this is a symbol representation. Right. So this is a mathematical product. This is a mathematical expression y equal to a, y equal to a into b into c. This is about AND gate operation. Now another gate I am going to talk about, OR gate. So OR gate, so the output will be high if any one of the input is high. Okay, na? So for example, this is a symbolic representation of symbol of OR gate. So like this we have to draw very clearly. This is about OR gate. Clear? Okay, I'll draw once again. So this is about the OR gate. Okay. Okay. So here OR gate has 2 or more than inputs and output is only one output. So this is a 2 input and OR gate. Output equal to y equal to a plus b. So previously we have discussed AND gate. The output is a product of two inputs. But OR gate is the sum of two inputs. OR gate nothing but what? The sum of two inputs. Okay, now so that's why I'm taking here a, b are the inputs and 0 0 0 1 1 0 1 1. The output y equal to a plus b. Okay, now 0 plus 0 0 0 plus 1 1 1 plus 0 1 1 plus 1 means 1 because both inputs are high, output is high. This is a logical operation, Boolean operations. Okay. Now we can say that if any one of the input is high, my output is high. In the OR gate, we are going to get if any one of the input is high, output is high. If any one of the input is high, output is high. If both inputs are high, output is high. But whenever we are giving both inputs are 0, output is 0. This is about OR gate. Okay, now here I gave 3 input OR gate. This is a truth table for 3 input OR gate. So 3A, B, C. So 3 variables are there. So that's why I'm going to get 8 combinations. Okay, na? So anyone. So if any one of the input is if any of the input is high, output is high. If any one of the input is high, output is high. Okay, na? So everywhere you can check the input is high, output. But whenever all the inputs are 0, output is 0. This is about the OR gate. Okay. The expression for the OR gate is y equal to a plus b plus c. Okay, na? It's a mathematical expression, and this is a truth table, and this is a symbolic representation of a OR gate. Okay. Next, we are going to talk about a buffer gate. So buffer gate, right? So buffer gate is in the output will be okay na equal to the input. So whatever input you are giving, same output, same input will be appear across the output side. For example, I am giving 0 my input, I'll get 0 my output. If I am giving 1 is input and I am going to get 1 is output. This is also called as a transparent gate. It is also called as a transparent gate. The output will be same as the input. Very clear, the output will be same as the input. That is, it is connecting wire in a digital circuit. Okay na? So if you want to pass a signal from one place to another place, simply I can use the buffer gate. So it is a connecting wire in digital circuits. Okay, this is a buffer gate. What I am giving 0, I am getting 0 my output, and 1 my output. Clear, no? The mathematical expression is y equal to a. The mathematical expression is what? Y equal to a. This is about buffer gate, and this is a buffer gate, right? So y equal to a output, and this is the NOT gate. Okay na? So y equal to, sorry, a equal a bar. Okay, here y a I am giving y equal to a. So because of this bubble, right, it will be invert the input signal. Okay, so this is a difference between, okay now, sorry, it is simple, it is a buffer gate like this one. This is wrong. Okay, just a second, I will draw again. Right, so this is a simple buffer gate. Okay, actually I drawn this. No, this is nothing but a PN junction. Did you remember? This is a PN junction. This is PN junction. This is a buffer gate. This is a NOT gate. Okay, so this is about basic logical gates. Thank you very much. Thanks.